Between 2009 and 2018, pedestrian fatalities increased by 53%. 90% of this increase was comprised of nighttime crashes. In 2018, 76% of pedestrian crash fatalities in the U.S. occurred in dark conditions. Most new vehicles sold in 2018 had advanced driver assistance systems equipped with Pedestrian Automated Emergency Braking, also known as PAEB. This enhanced automatic emergency braking feature enabled vehicles to avoid collisions with not only large objects such as vehicles, but also vulnerable road users including pedestrians and bicyclists. Even though most pedestrian fatalities occur at nighttime and in dark conditions without streetlights, current new vehicle testing protocols largely do not evaluate the performance of PAEB in those conditions. Independent tests conducted by the National Highway Traffic Safety Administration, or NHTSA, and AAA reveal that in every scenario considered, current PAEB systems frequently fail to protect pedestrians in dark conditions. AAA found that in dark conditions, none of the 4 vehicles tested alerted the driver or slowed down for a pedestrian target crossing the road. Velodyne has been developing and testing a PAEB solution that works equally well at night and during the day. Velodyne's PAEB solution combines proprietary software called Vela with LiDAR sensors. These sensors can be easily embedded in a variety of places around the vehicle, including behind the windshield. Velodyne's Vela software interprets LiDAR data to avoid and mitigate crashes with both moving and static objects. Through predictive collision monitoring, Vela compares a vehicle's trajectory with that of other road users and objects in order to identify and avoid imminent crash scenarios. To demonstrate that improved nighttime PAEB performance can be achieved by implementing readily available LiDAR technologies, Velodyne's LiDAR-based PAEB system was tested against a highly rated PAEB system built around camera and radar. The tests were conducted at a driver-controlled speed targeting 30 miles per hour on a straight track, 1 hour after sunset, with less than 1 lux ambient lighting. The 2 test vehicles each had their low-beam headlights on during the trials. The scenarios in which vehicles were evaluated included crossing adult at 50% overlap at the center of the test vehicle's whip, crossing adult at 25% overlap, crossing child at 50% overlap, crossing child at 25%, adult at 75%, 10 feet behind child. Crossing adult at driver's side corner. Fallen adult at 50% overlap. The results of these nighttime tests support the findings of AAA and NHTSA that camera and radar-based PAEB systems frequently fail in dark conditions. In contrast, Velodyne's LiDAR-based PAEB system, equipped with one Veloray LiDAR sensor, successfully stopped in time to avoid a crash 5 out of 5 times for every scenario tested. The availability of affordable LiDAR-based PAEB solutions indicates that improved nighttime performance is a reasonable expectation for regulatory and testing agencies to implement in assessment protocols. Therefore, vehicle assessment organizations should expand PAEB testing in ambient light conditions of less than 1 lux. Velodyne's Veloray LiDAR data and Vela processing software is effective and ready for implementation, with the potential to save the lives of thousands of pedestrians annually.